Okay, so A section dark is probably the primary layer for the wall section. So you can change the other layers if you need to after the fact, but this is what I would start with, A section dark. And again, I would start kind of outside in one of the corners somewhere where you can actually build it. And to start off with, I would kind of think of it like building the wall. Start with the foundation, then do the first floor framing, then do the floor framing, then do the second floor framing, and then do the roof truss. And then we can come back after the skeleton is there and put the materials on it. So that's the best way to approach it. So two things. So how wide was our concrete beam in the foundation?
10 inches.
10 inches. How deep was the slab? Do you remember?
4 inches.
4 inches. So offset 4 inches. I mean, I'll obviously draw a couple of lines first, but offset 4 inches this way, offset 10 inches this way. Those beams typically are about, from the top of the slab to the bottom, are about 24 inches deep, so offset 24. And then at least fillet the beam together down here. Now, to hold the slab and the concrete beam together, they usually put in a 45-degree angle here. Has nothing to do with really the slab or the beam. It's basically being able to connect the two pieces of concrete together with the steel and hold it together. So they usually do that at a 45, and according to this, that's 3 3/4 of an inch. So you could do that a couple of ways. You could either, you know, offset 3 3/4 of an inch in both directions, or you could use what's known as chamfer or camphor. I'm not really sure how to pronounce it. And down here you'll notice it gives you a whole list of stuff. If you type in D for distance and then type in 3 3/4, then enter that, and then you have to specify the second. It's the same thing. It's the 45-degree angle. Can't have a 45-degree angle unless both sides are equal. And then you select outside of that 3 3/4 of an inch, and it'll automatically put the 45-degree in at the 3 3/4 of an inch. All right. So the other thing we want to do is kind of make sure we're lining up the left side of that all the way up. This is an arbitrary thing just to put it on the sheet. It has nothing to do with the actual wall section. This is the practical thing just to figure out what we need to draw. 3 5.5, 3 6, something like that would work just fine. So offset 3 5.5 or 3 6, that doesn't really matter as long as it's close to that. All right, and then this is really a construction line that will go away, so I'm just going to extend it on up. All right, so we've got basically the concrete here. 4-inch slab, 10 inches for the beam, 45 here at 3 3/4 inches vertically or horizontally. The next thing I would do is put in the bottom plate, the sole plate. That is going to be an insert out of the wall sections in the shared directory. Wall section. All right, not flashing, framing lumber. All right, so this particular block is partially dynamic. That's not really a good hot point, but I'm going to go ahead and put it on that intersection and then move it up, because the face of the plate there should be in line with the face of the concrete, but sitting on the concrete. Now, when we drew the floor plan, how wide was the walls on the exterior, perimeter walls? What did we use for the perimeter walls on the plans? 5.5, which is a 2x6 wall. So this plate needs to be 5.5. So let's see if it is. All right, I can't tell, and it's not giving me. Let me see if I move out a little bit, see if it'll do it.
Over it, you want to see. Okay, it's 5.5 of the triangle.
Yeah, it's giving me that. I think there's something turned off in the, it's either turned off over here. Let's see if my dynamic is on. Sometimes it's down here. Dynamic, where's the dynamic? That's not what I want. That's not what I want. Where is it? I need to find the dynamic input. I don't think it's turned on. Let me go back here again. Ah, see this? Dynamic input. I'm going to turn that on, see if that makes a difference. Still didn't make a difference. Okay. Alright, well, now that it's turned on, where did it go? There it is. So that was turned off in the customization over here. So sometimes something is not showing up that it should be. It may be the fact that it's not checked to be on down here, and then even after that I had to turn it on down here. Now that I've got it turned on, the dynamic input is both down here. I've got it turned on, so now when I on top of the triangle, it's telling me it's 5.5. And the other direction, because it's a 2x, should be 1.5. So that's the correct size. So then the stud sits on top of that. And according to the elevations and the roof plan and also this wall section, at least the roof plan, the top of the plate for the first floor is 8, 11, and 5/8. So I would offset 8 feet 11 and 5/8. If you want to use the decimal, it's 0.625, or you could do the space thing with it, make it work. Alright, so here we have a single top plate. It's going to be the same symbol that we had down here. So let me double check to make sure I put that in right. 8, 11, and 5/8. Yep. Okay, that's good. Alright, then sitting on top of that is the I-joist, the floor system basically, and it is called out as 11 7/8 joist rim joist, but it's going to align with the edge of the framing just like before. It's an insert. This is the roof truss, so it's not that one, it's the I-joist. So it aligns with the outside edge of that framing there. And in this particular case, the way they're building this, they're putting 2 layers for the flooring, one for decking and one for the actual flooring. So it's a 3/4 inch plywood floor decking and a 3/4 inch reclaimed wood flooring on top of it. But they're running the decking all the way to the edge, and it's 3/4 inch according to the wall section there. So offset 3/4 inch. 0.75 is the decimal. It of course will run in alright, so I was just talking about the decking. Well, guess what? The decking's not on the bottom of the truss. It's up above, so I drew that in the wrong place. I was thinking it was the top of, and that's the top of the plate, but that's not the top of the truss. So it's going to run all the way out to here, and it's going to be on top of that. So the 3/4 inches is going to begin here. And I'll set that to 3/4 of an inch. Alright. And then on top of that, even though it's not the finished floor, they're going to put the bottom plate for the second floor. And then they're going to have the actual wood flooring on top of that, which is another 3/4 of an inch. And that runs into the plate. And that's actually the finished second floor here. So the plate's actually a little 3/4 inch down because it's sitting on the decking, but they're running the flooring into the plate. This is considered the second floor finished floor. And then on top of that, we're going to have a stud that goes up to the second floor plate. That plate is 18, 11, and 7/8 from the finished floor down here. So offset 18 feet, 11. I think if you put in a dash and then 7/8, it should work. Yeah. So a decimal would work too, either way. And then you would have your top plate, again, same block that we've been using for the plates. Just to make sure I've got that in at the right height, I'm going to double check it. It should be at 18, 11, and 7/8. That's correct. Alright, so we've got the concrete foundation, the first floor framing, the I-joist here, the second floor framing. On top of the second floor framing is going to be the roof truss. This is a raised heel truss, which means they raise it up at the end so they can get insulation in there. A normal truss, they would actually pinch out at the end into a triangle, but the raised heel, they engineer it to where they can raise it up a little bit to get insulation in there. So, as I recall, the truss itself is on A-section light. Let me double check that, but I believe that's true. Yep. Alright, so change your layer to A-section light. Another insert. This time it's the truss dry, and it still aligns with the edge of the framing. This is the raised heel portion of it. You know, with a normal truss, this would be further down and it would be more of a triangle lower. But this is known as a raised heel. Okay, so that essentially gets in the framing and the concrete for the wall section, and it's critical that all that stuff's in the right place, because if it's not, it'll throw everything else off. Alright, so let's go back and start building from the bottom down here. So down here at the concrete, they're going to have a vapor barrier, then they're going to have clean fills, basically clean sand most of the time. And it shows up as a gravel on here, but it's usually they put in sand for the but they're going to put in stone on this one, kind of a larger gravel. It can be done either way, but it's more typical to have sand. And then underneath that is undisturbed earthwork, which basically is just the soil for the ground that hasn't been moved. So it looks like this. So we're going to use 1/4 of an inch down to the vapor barrier. That's to keep the water out of the concrete, because remember, concrete and masonry both is very porous, so you don't want any water from the ground getting into the concrete. So that particular layer is A-section medium for the flashing. So you can offset 1/4 of an inch. And the other thing is, in reality, you know, there is no distance between this vapor barrier, because it's like a polyethylene, kind of like a trash bag, kind of that same type of thing, but it's in between the sand and the concrete, and there's really no difference. But this is one of those exaggerations in architectural drawings. It's a graphic convention, because if you didn't do this, you wouldn't really see it. So they want to make sure that you see it, and they offset it a little bit so they can call it out. And I didn't offset the layer, so I offset to the same layer. You could have set this over here to layer, let's see, have to do it on the first one, layer, and then you say current, and then you can do it, and it should offset to the right layer. Forgot to do that. So now I've got to go back and just match properties and erase the line I just put in. So this line really isn't there. Need to fill it together with the vapor barrier. And then they're putting in the stone gravel here for the select fill, sometimes they call it. We're going to use that same 3 3/4 inches down, and this is going to be elevation light. Really the only reason that line is there is to separate the hatches, because it is different between the gravel and the undisturbed earthwork. So a section light somewhere up here, there it is. Offset the same 3 3/4 that is, and just extend that all the way across into the concrete. Again, there is no actual distance between this and that, so kind of an exaggeration. And then we've got to find a way to put in the earthwork. Well, as you know with hatch, you can't hatch anything unless you've got an enclosed area. So we need to put in the ground line and then put in some construction lines to do that. The ground line is approximately 10 inches below the finished floor line, and we also have the sheathing running down all the way down to here, and then from at least the second set of sheathing, it changes here to like a hardy board, so it doesn't get moisture through it as much, and then that's like a 5/16 board. So up above, if you look at the call outs on the handout, you're going to see that it's 1/2 inch foil face polyethylene, I think, don't remember the pronunciation, insulated sheathing with all joints sealed per manufacturer to be used as drainage plane and radiant barrier, and then 1/2 inch exterior sheathing. The sheathing's next to the stud. The foil face is on the outside of the stud. That's a radiant insulation to reflect heat back out. So, but they're both 1/2 inch until it gets down to the finished floor. The first 1/2 inch continues to run down to the base. This one stops, and then it picks up with a 5/16 inch fiber cement panel. So we're going to offset 1/2 inch for both the sheathing. Didn't change my layer back. A section dark. Offset 1/2 inch, is still on the elevation dark layer. Alright, so the first sheathing there is going to go all the way down and match up to that. So I'm going to fill up those lines together. The next sheathing essentially goes, I believe it's about 13 inches down. Let me double check. Yeah, 13 inches is close enough. Alright, so offset 13. All right, so this one stops here, and then the 5/16 begins below that. Fiber cement's basically hardy board. It's kind of a moisture resistant barrier. And it goes down to the 13 inches we just talked about. And that'll stop there. And it looks like I filleted too much because this should stay here. The other one should still be going down to there. I wasn't watching what I was doing. Alright, so the first ½ inch is continuous. This one changes to the 5/16 and comes down to here, 13 inches down. At that point, we need to draw a ground line, which is about 10 inches down. So as a construction, you can draw this and offset it 10 inches down from the finished floor. And then your ground line is going to be on a section cut. And then just slightly slope it away. Showing the ground sloping. Alright, and then we've got to put in the hatches there at the foundation. Right now we don't have anything that here. Usually you show the earthwork going down and underneath the beam and out in front of the wall section here. So I'm just going to draw, based on what I've got here, a line down. You can eyeball this. If there's no right or wrong answer, I'll give you some dimensions here in a second. But basically where you can close off things. So the total of mine is approximately $410, $411, somewhere around there. And then down from the bottom of the gravel there, I came down about 2 feet 4. So for my purposes, I'm just going to copy this over, but it'll be on the same drawing for you. The main thing is you've got to have this enclosed all the way. Looks like I sloped this down maybe a little bit more. The line you'll get rid of anyway. So the hatches are on the pattern layer, as you might expect. Concrete is that 1.0 hatch. It's AR-CONC, stands for architectural concrete. And it's a typical symbol for concrete. This one, 1.0 or 1. And so this is pretty typical for concrete, to show it with the triangles and sometimes with circles and dots. Except that's not the concrete, that's the earth. Concrete belongs where the foundation is, so let's try that again. And yes, there would be reinforcing steel, but we're not going to worry about showing it here. We'll let the structural details take care of that with the structural engineer. All right, and then here is going to be that gravel. Like again, usually they use sand, but in this wall section we're using the select fill of gravel. And it's going to be a 2.0. It has its own pattern. Find it and know it's there. There it is. Instead of 1, this needs to be 2. And then for the earthwork, no surprise here, it's called earth, but the scale is quite a bit bigger. This is one of those patterns back in the day. If you got too dense, it would crash the program. Doesn't do that anymore, but it did at one time. All right, earth. Change it to 15. All right, and then once you get all that in there, you can come back and erase your construction lines back out. Alright, on the inside here we're going to have sheetrock, and it's going to be 1/2 inch sheetrock, so offset 1/2 inch. Apparently I'm on the wrong layer, so it needs to be set to A section dark. It runs up to the ceiling, which has a 5/8 inch ceiling, not 1/2. The ceiling is going to run into the plate. And the wall sheetrock is going to run into the ceiling. Then up above, we again have 1/2 inch sheetrock on the second floor. It'll run down to the decking, and the flooring will stop at the sheetrock. And then at the top of that, we'll have the same condition we had before. This is a block. I would leave it as a block. So go ahead and draw your sheetrock line over the top of it. And then offset 5/8, because you have to have 5/8 for ceilings. And just like below, sheetrock here will stop at the sheetrock at the ceiling. Alright, so these two sheathings will continue up. We don't know exactly where they're going to stop yet, so I'm just going to extend them all the way up to the truss. We'll have to come back and clean that up in a minute, but these will continue on up. Then down here at the foundation, they're using some flashing. And I forgot to extend my sheetrock to the floor here. So we need to put in the flashing here. It's also used as a termite shield. We're actually more than 8 inches out of grade, so technically it's not required, but it's not a bad idea. It's a flashing, so it's going to be an A-section medium. It is an insert. It is the bottom plate flashing. We will put it in and then move it. Alright, so I would put it to where it's aligned with the 5/16 of an inch. Alright, then I would move it actually diagonally down to where it's actually here, just on top of the fiber cement board and at finished floor level. I understand what they were doing when they put the reference there with the point there, because they were just trying to make sure you could see it better, but it doesn't really read right, I don't think, so I'd rather it be here. Alright, and then on the outside of this sheathing here, we have what's known as a vent screed. It's basically to allow air to go behind the siding and not get a complete thermal heat transfer from the siding through the sheathing. So that's going to be believe on A elevation medium 2, section medium. So insert, it's another insert. What's it called? Siding vent. All right, so that's going to come in at there, so we need to align that with the sheathing here. Now up above that, and in between these vents, there is open air, but they still have to put something to tie things together. So there's a 1x4 flat. So instead of being 1x4, 3.5 inches out, it's a 1x flat against the wall. So it's only 3/4 of an inch out. That's going to be an elevation light. I keep saying elevation. I mean section light. And it's going to run all the way up as well. We'll come back and correct exactly where that's going to stop at in a little bit, but right now just run it all the way up to the truss. And then on the outside of that will be siding, but we need to put that in pretty much last. So that kind of constructs the basics. So now we're going to go up to the roof. It gets a bit tricky, but remember how far out is our overhang from the frame? How far did you draw your roof overhang on the roof plan?
2 feet.
2 feet. So from the edge of the framing, not the sheathing or that 1x4, which is 3/4 inch here, it's 2 feet out. So drew a construction line, then I'm going to offset that 2 feet out. I'm going to stretch it down. All right, so that's the edge of the overhang. So, but we also have, and this is actually not called out anywhere that I know of on this, it's just called, the only thing it really says on these wall section is roof underlayment over roof sheathing with integral full face facing down. That's great, but it never really tells you the size of the sheathing. And I guess that's because it could vary. But for our purposes, we're going to use 1/2 inch. Show you where that is. Basically from the, here's the truss, and then from the top of the truss there up to the top of the sheathing is 1/2 inch. And because the truss is a block, you can't offset that, so draw over the top of the truss and then offset it 1/2 inch. So still on the elevation dark, so over the top of the truss here, and then offset that 1/2 inch. And then the top of that plywood sheathing is going to be the corner right top of the trim board where our overhang is. So if you fill those lines together, this was the 2 feet out from the framing, this is the 1/2 inch up from the truss. That is where the 1x2 drip edge is, and you're going to use the same block as this. You just have to modify the size. So a 1x2 is 3/4 inch by 1.5. So the upper right corner of that 1x2 belongs at the intersection of the top of the 1/2 inch plywood and the 2 feet out. All right, and then based on that same line, basically where it's coming off of the top of the plywood here. The next thing is going to be the 2x8. And again, you can use this. Remember, this is a 2x6, not a 2x8, so we need to change that to 7 1/4. Have to rotate it. Then I'm going to move it over, at least to line it up here to begin with. It's not the final location, but you can see how this side of it lines up with that side of the truss. Then I'm going to draw a temporary construction line like this and move the entire thing up. And then I'm going to extend the bottom of that sheathing, plywood sheathing, down to where it hits the 2x8, and that's the actual end of the sheathing. So you would draw a perpendicular line. So in reality, that line right there wouldn't be there, but for convenience, we're going to leave it in because it just makes things easier to draw, and it's not going to confuse anybody. All right, and then on top of on top of the plywood sheathing, there is building paper, basically to help slow down moisture from penetrating through the roof. And then the metal standing seam roof on top of that, which is going to be 1 inch. So the actual dimensions on that from the top of the plywood to the offset for the wall, the roof paper here, which there actually in reality there is no distance, but I believe that was another 1/4 inch if I remember correctly. I will double check. Yeah, well, no, I guess it's 1/8 inch. I was wrong. 1/8 inch out to the medium. And then above that, that's not an aligned dimension. Let's try that again. All right, I was thinking of the what's above it. So it's 1/8 inch, and then 1/4 inch, and then you have 1 inch for the metal roof. So the first offset, it's 1/8 inch to the medium layer. And we may need to move it slightly in a minute, and you'll see why, but right now that's where we're going to put it. And then before we put in the next one, let's put in the flashing up here, because that's really where this line is going to be determined by. All right, so same layer. It's going to be the roof flashing, and we'll see if it's even close. We're going to put the roof flashing in, and it says it's right there, but we're going to move it to where this bottom of the flashing here is going to align with there. I think it reads better if it's like that. All right, so technically speaking, that 1/8 inch that I just put in is not really 1/8 inch. It really should be coming off the end of this flashing. So I'm going to move it to there, and then I'm going to trim it back. So basically put the flashing in, and you could put this in to begin with 1/8 inch, but then come back and actually come off the end of that end point there to make sure it's in the exact right place. And because you want to align it up to where we're cutting things off over here, you would extend those lines on up. And then for the metal roof, the one that was 1/4 inch up, and those are general dimensions, I would really just use the flashing as you go by. Go to your A light layer, and then you could copy off here and attach it to the end of the flashing here and change the layer. So really, this piece of flashing is determining where the building paper and where the bottom of the metal is. and then offset that an inch. And then do a perpendicular for the middle end here. And then continue it on up to the construction line there. So I would say just kind of ignore this, put in the flashing, and then determine, you know, that these are going to come off the end point of the flashing in both cases. And then an inch for the metal up here. All right. This was a construction line, so I'm going to erase that. Underneath here is a soffit board that is 5/16 fiber cement soffit, basically a hardy board soffit. So off again, you're going to have to draw over the top of the truss there, and it starts at the sheathing. I'm on the wrong layer. I need to set it to A section dark. Then offset that 5/16, similar to what we did at the bottom of the wall section, except this is the soffit board. Make sure it extends all the way across. This will stop up here at the sheathing. And then the sheathing itself actually stops here and there because it's running into the truss. Alright. Yeah, then this was coming up from below, but there's more stuff going on here in front of the sheathing. So what I'm going to do is not block, break this line and erase the very top part of it. It didn't break for me. Okay, and I'm going to undo that. And I'll just stretch it down. As long as your ortho's on, it's easy enough to do. Up here we have a 1x4 in front of a 2x4. So if we put the 2x4 in first, we can locate where it needs to be. Again, we're going to have the same block as we've used for all the rest of the structural framing. We just need to change it to a 2x4. So 1.5 by 3.5. I'm going to set it up against the wall here, and then I'm going to draw a construction line to know where it hits the slope up here and move in basically this intersection or end point to the intersection here. And then in front of that there is a 1x4 which is 3/4 by 3.5. And move it to where it hits the soffit. Alright, and then because the siding needs to end up behind this 1x4, we need to put the vent at the top, the polypropylene siding vent. It's the same block that we used at the bottom, but we're going to come 1/4 inch off here. So I'm going to set this to A section light. I'm going to draw a line. I'm going to move it down 1/4 inch. And I'm going to extend this on up. I guess I'll fillet it in this case. And then we still need the block. You could either reinsert it or just copy this one up at the top. All right, so that makes the siding go behind, so that leaves us with the siding to put in. The siding is actually a rectangular array with pieces at top and bottom that have been separated out to be a separate piece because there was no way to get it in and be even all the way up and down. So if we come to begin, I think I used that same 3 3/4 of an inch to actually start the siding for the array. In other words, from, maybe it was from the frame, we'll find out. 3.5 from there, so the 3 3/4 is from here. Yeah, from the actual bottom of the frame there. And then the actual array, I think, is 36 rows, 6 inches, and 1 column. Which doesn't line up exactly well to begin with, so we'll have to modify that. Anyway, so our construction line then is for the top of it's going to be, all right, 3 3/4 inches down. I'll just leave that as a construction line at the moment. Now, we've got to create the array, so this is only section medium. Insert. This is, where is it called? Solvent bin, siding bin, siding fiber cement drawing. All right, so it's just going to come in as a vertical block, so we're going to need to rotate that. And I don't know that this is written down anywhere. Rotate it 2.468. All right.
Is that 468?
2.468. I kind of did that on purpose just so it'd be easy to remember. 2.468. All right. And then we're going, because it's a lap siding, so we're now going to create the array. So the array always defaults to a certain look. So if you select this and then go to modify and go to array, it's going to be a rectangular array. It always does this. It's automatically going to give you 4 columns and 3 rows. I don't know why, it's just what it does. Our number of rows needs to be set to 36. We only have 1 column, so the column is actually 1. And then since we're using a 6-inch lap siding, we need to set the distance between to 6 inches. So then once you do all that, it should look something like this. And now we can move the top of this to where we constructed, and you can see it's going to go down most of the wall, but this last piece is not as big as this is, nor is the top, so we're going to have to reinsert and basically do a separate piece for the top and bottom. That's what it amounts to. Alright, so we're going to reinsert that same piece again. For the top, we're going to kick that out the same 2.468. But here's the problem. When we come over here, that doesn't line up very well. It gets into the screed up above is where it's supposed to be. So what we're going to do is actually put this over the top of the one below it, so it's actually aligned, and then we're going to move it based on the distance from endpoint to endpoint here. So that's where it needs to be, but you can see it's well up into the 2x4 wood framing there. So we need to modify it. The only way to do that is to explode the block, change the layers, and then stretch it. So we're going to explode the block, and then we're going to rechange the layer back. Match to the correct layer, which is that. And now we're going to basically stretch this down, and I don't care if it hits this or not, but I need it to be at the same angle. So stretch works by crossing the endpoints you want to stretch. Alright, so you can see the ghost lines there. Stay on top of the ghost lines and kind of line it up with the top of the vent. Just like that. And then it reached pretty well. We'll do the same thing for the bottom. This one actually has to kick out further, but we're going to do that after we create it. So down here, we're going to reinsert another one. So the top and bottom pieces are separate from the most of the siding. You have to do those as separate pieces. Our mouse will cooperate. There, okay. Alright, so I'm still going to rotate this at least to begin with. That same 2.468, although we'll change that in a minute. I'm still going to do the same thing I did before, so I'm going to line it up with the one above it, and then I'm going to move it down from endpoint to endpoint. All right. But what we don't have in here yet is the water table trim, which is that resin created water table trim to keep water out of the framing. So we need to insert that so we know where that needs to end up. Either way, this is going to change. So I'm going to go ahead and explode this right now and then go back and match properties to the correct layer. We need to put in the water table trim. Remember the infamous water table trim from the elevations? It's the same thing, but this is a little more detailed. Water table. It comes in backwards for this wall section. It needs to turn the other direction, so we're going to mirror this with the ortho on. Yes, we want to erase the source object. Alright. And so what I want to do is I want to take where this arc ends right here at that end point, make it a little lower than that vent there, and put it right there. So when the water's coming down, it comes off the side, it runs off the water trim, comes here, comes up, and drops out. If that notch wasn't there, we'd run all the way back into the framing. Alright, but you can see the siding now is literally into the water table trim, so we can't do that. So all we need to do is rotate it a little bit further out. You can highball this. What you need to do is get that as your point, take the ortho off, get it fairly close to where you need it to be, somewhere like that. That's still kind of overlapping, and then I would come back and stretch based on those ghost lines. You can kind of see the gray lines right next to the green line there. Kind of keep on top of those. And then, that's probably good enough. Because what we're trying to do is show the siding come down, the water coming off of that, and then basically running off of that. And if you wanted to, you could actually get it right in the corner there. When it prints, it'll bleed together. It'll be in the same place. Okay, so now we need to put in the batting. The batting is not a hatch. It is a line type. It was one of the layers you created from before. It is not a pattern. It's going to be on the insulation layer. It's this batting line type. If you didn't know how to do that, remember you can come over here to the line type and select it, and it'll bring up a list. And if it's not in there, you can go to load and then look down through the list there and say okay and okay, and it'll show up. Anyway, so anyway, that's specifically for this A-section insulation layer, 252 batting, but it is a line type. It's not a hatch. So to draw that, you draw it as a line. Draw it from the midpoint of the plate to the midpoint of that one, and then do the same thing above. How you notice it's too big. This is a conflict between model space and paper space and hatches and line types and all that. So if you get it right if you get it to look right in model space here, it's going to look wrong in paper space. So it's one of those weird AutoCAD things. So our line type scale for the wall insulation needs to be changed here to 17. And then it's going to appear probably as really large. But that's okay. That's what it's supposed to do. In addition to that, we've got honeycomb insulation. It's a closed cell spray foam insulation. Technically, open cell is better for our climate because closed cell doesn't allow any air movement at all. It tends to trap the humidity and the moisture, so they've actually recommend open cell. It's very similar, except it actually allows some air movement through. It goes at the floor system and at the ceiling system. There's no right or wrong. You can eyeball that. I put the in arc for the hatch on the medium layer. I don't know that it matters that much, but I'd go ahead and put that on the medium layer, and it's just an arc. Like I say, just eyeball that. All right. Before we put that in, we need to create the insulation baffle. And on those details, it says that the insulation baffle is to maintain a 2-inch air passage under the roof sheathing. So basically, under the roof sheathing. So off the bottom of the sheathing here, offset that 2 inches, the sheathing itself. Not an insulation layer. We need to put that back to A-section dark. And then that actually ends where the sheathing ends. In addition to that, out here there's a soffit vent more or less located in the middle. You can eyeball that. I think mine's a little higher than the middle, but you could use the midpoint if you wanted to. That's an A-section medium item, and it's going to be under the inserts. Soffit vent. It's probably better if you do use the midpoint. Mine's a little high. Now, I didn't have my rotate on when I did that, so I'm going to go back and reinsert it. Rotation specify on screen. Go back to the midpoint. And then if you take the ortho off, you can align it with the endpoint down here, and it'll be at the correct angle. Now this is getting air through, so the sheathing's not continuous through there, but you do see the backside of the framing there. So what we need to do is trim out those lines. And that's showing the vent, soffit vent. The air comes up through there. Here's our baffle vent to get underneath the sheathing and above the what's happening below, and for the air to go out through the ridge vent. And then now we have the baffle vent in, so we can finish the honeycomb, and that's insulated all in there. It's going to be, like I say, it's called out as a what did I just say? Closed cell. Open cell is more recommended for this area, but whatever. They spray it in, and that's going to go on the pattern layer. And it's called Honey, and it's 6.0 for the scale. This one looks like a honeycomb, basically. And that's all the way up to the baffle. Same thing would happen at the floor system. All right, and we still got the insulation to draw at the top. This gets real tricky. You almost have to come back and fix this, and well, you do have to come back and fix it in paper model space because you can't really see it very well. But the adding insulation, we're going to use bad insulation as the symbol. Technically, it's a blown insulation. They wouldn't put bad insulation up there. They put in blown insulation, but there's no good way to show blown insulation, so we're going to show the batting symbol for it. And that's going to be another line on the A-section insulation layer. So I'm going to arbitrarily draw it in right now. This should be 34 in the line type scale in model space. See how it changed to a line, so you can't really tell where that really goes till we actually create the viewport. And it's going to run pretty much in to where the plate is over here. I mean, not the plate, but the metal gusset. All right, this is one of those things that you have to select the line and then grab it by the endpoint before you can really do anything with it. All right, that'll likely have to be shifted up or down one way or the other. And in addition to all that, which creates the wall section, now we've got to put the detail bubbles in so we can reference the details on the same sheet. Those are drawn by drawing a polyline. They're on A-sect ANOSIM, so you can turn them off in the larger details. They have a 45 degree line going into the section bubble. All right, so, but initially to draw the bubble, it needs to be on the ANOSIM layer, which is not part of the wall section itself. It's a separate thing. A section ANOSIM. It is a continuous line because of the bubble with the text and the other lines, but the actual bubble is going to ended up being changed to hidden. All right, so it is a polyline. So the best way to do this is to draw it as 4 separate lines first, kind of out to the side. The size doesn't matter at this point. We'll change that after the fact. We're going to fill it to make it rounded corners at 7 inches. So fill it, change the radius to 7, then pick the lines. you can assign a global width thickness to a polyline. So if you select this, right click, go to properties, over here there will be something called global width under geometry. Change that to 1 and it will make the line thick. We're also, it's going to stay on that asect anosim layer, which defaults to the continuous line. The bevels need to be hidden, so change that to a hidden line type. This one. Alright, and then that goes around what you're trying to describe in the details. And if you look on the left side of the page and on the right side of the page, you can see where the dotted lines are around the wall section. Like at the top there, that detail 2 is on the left side. That's a blow-up detail of that same area. So this would be moved back over here. And right now it's too small, so I'm actually going to leave it out here and increase the size of it a little bit. If you use stretch, cross the endpoints of what you want to stretch and keep the ortho on, it's easy enough to change. Let's see how that fits. It's got to be wide enough to get all that detail, and it's not quite wide enough yet. I need to be a little bit more wide. Turn my ortho back on. That may be too wide, we'll see. No, that's not too bad. Alright, it's not really high enough because we need to get that dimension in there. There will be a dimension on the asect anotim, which is here for the 2 feet. Let's see how much I need to change that. Just a little bit. Oop, didn't mean to erase it. I'm going to stretch it a little taller. Make sure your ortho's on when you're stretching. Alright, something like that, so we're forgetting this area. Same layer, not dims, but the section anosim. Draw a 45-degree line off the midpoint of the arc here. I would use F10 for polar, but it would turn off the video if I did that, so I'm not going to do that. So what I'm going to have to do is just construct it. Say line. Let's see, at 3 feet, angle 45. Too far down, but that gets my angle in there. And then create a landing. Let me draw a line here. Landing is the horizontal line. That's what I'm talking about. Yep, okay, so the fillet, I forgot to change it back to 0. I need to do that. Fillet radius 0. I now need to put in the detail bubble itself. And let's see if it's in here, not there. Alright, that's probably under annotations then. Alright. detail bubble. Panel detail bubble is the one. Alright, and then you line that up. And then move it over to wherever that is. And then of course, you would change by double clicking on it, whatever it is. This happens to be detail 2 on sheet A3.1. Sheet number always goes on the bottom. And then you would do the same thing for the other two here. So a lot of times when you change this, the other thing about this is for this to show up right in paper space, we need to change the line type scale. For these, it's 32. When you change that, it looks like a continuous line, but it's still the hidden line in paper space. Alright. After you get all that done, you put that in, and then come back and put in your benchmarks. Similar to what you did on the elevations. It's the same block. You know, line up the benchmark edge here. You can see they're all lined up all the way up and down. Then come back and put in your text and make sure you're putting the text in and these in at 3/8 of an inch for the wall section here. Now, let me show you what's happening with this. I'm going to create a I don't know which one do we use here. It doesn't really matter. A temporary layout here to show you what you'll need to do. I don't think that's roof 2. Alright, so you create the wall section. There will be actually 4 separate single viewports for this, but I'm going to show you the first one. So as always, you want to set your viewport layer to XVP off before you create the single viewport. And that viewport, I mean, of course we've got to be looking in the model, and this has got to be unlocked. Alright, so that wall section I just drew was this one. So you would set your, in the wrong place, you set your annotation scale to 3/8, because that's basically what it's drawn to, and you would lock it. Alright, so in here, of course, if you want to turn that grid off, you just hit F7 or the grid down here. But see how this line is appearing right here? It's a straight line. That's that batting insulation. Same thing up here. And you can see these lines are appearing as continuous, just like they were in model space. To correct that, we have to type in PS LT scale. PS paper space LT line type scale. And set it to 0 for each one of these viewports, but only for this sheet, not for any of the rest of them. Once you do that, nothing changed. You've got to regenerate. So RE for regenerate, and then this is how it looks in paper space. Still looks weird in model space, but at least it's appearing right in paper space now. And here, this is that line we couldn't really tell where it was. You have to grip that and basically just move it up, kind of eyeball where it is. You might be better actually to use the move command rather than try to grip it, so let's try that. Because it needs, the insulation needs to be sitting basically on top of the ceiling line there. This is the gypsum board for the ceiling, that needs to be on top of that. So this is the one thing I say you need to actually do in the model space and the layout. Most of the time I say stay away from drawing anything at all in the models and in here in the paper space. Alright, so looking at the one I've actually completed, it looks like this. Now, you'll notice here, like we were talking about before, that the text is the same size. It's not the same size in model space when you put it in. If I go back to model space for the wall section, I've got up here, that's my completed wall section. That shouldn't have these lines anymore. I can change the annotation scale as long as these are kept off here. Particularly that one, because you don't want to add multiple scales. And this one, if I change this to 1 inch, the scale of the model space text is actually looks a lot smaller than the other one. It's because as you blow up the wall section to a larger scale, the text gets smaller in model space. It's the same size in paper space because of the annotative scale, but it looks smaller in model space, and you can put those in here. And I would put all the text and the dimensions and the liters in here. And again, you can put these together. I found that really tedious when I was doing it the first time several years ago. I'd still recommend separating the liters from the text, but you always need that horizontal lining on the end of the liter there. It's a multi-liter, and again, you're going to put it in at 1 inch for this scale drawing. But let me go back to the one I was kind of over here. So when you set up those viewports, same thing, XVP off, go to layout, XVP off, go to your rectangular single layout. Either one would work, it's the same thing. Then this becomes a bit of a challenge because you've got to fit all 3 details along with the titles. So, but for this detail right here, this is referencing, you know, that top detail. So what you'd want to do, get in your wall section here. This is the one I just drew. And these details need to be 1 inch, just like your annotation scale is going to be 1 inch for those. So let me set to 1 inch. Apparently I was fairly close. Alright, and then position it to where you need it. You may have to manipulate the viewport, you likely will. I scrolled rather than pan, so it just got off. Go back to 1 inch. If you pan, it won't change the scale, but you need to line this up to where you see what you need to see. You might have to actually increase the size of the viewport to see what you need to see. You got to be in paper space to do that. And we also have the bubble appearing. Well, remember we put that on a separate layer, asectantal sim. So in these viewports, you can come over and actually freeze that layer. But did I redraw anything for this detail? Not for the not for the major part of the wall section. The text you'll have to add, the benchmarks you'll have to add, but you could actually freeze because it's a separate viewport. It doesn't disappear over here, but it will. You can turn it off over there. The other thing is that line shouldn't be there anymore. That was my construction line, so I'm going to delete that. And you'll notice as I'm doing it in one, it's picking it up in the other because it's the same drawing. Alright, so let me go back to model space. So for your actual overall height of wall section like this, use your scales down here. Use the 3/8 for that one. Go to annotate, and of course use your annotative text. And And I'm just going to type something in real quick. I don't think that's on the right layer, so it isn't. Of course, that's going to be on asect anno text, I believe. Asect anno. Okay. And then for your multi-leaders, again, I would separate those out. It will just make things much easier. So if you take your ortho off to begin with, if you need to angle this, you can, and then you can turn your ortho back on, and then you can enter and escape, and you can move it to whatever, and then to keep those multi-leaders at the same angle, you know, you can copy it up and change the text to something else. Just makes things easier. So if the multi-leaders are close to each other, they need to be at the same angle. Make sure you're pointing to the right thing. So I put those in at 3/8 of an inch. So if we come back over to the one I created just a minute ago, you can see it appears here. So I'm going to go model space and I'm going to move this up. See, no matter where I am here, you're not seeing it on the other side because it was created specifically for 3/8 of an inch, not for 1 inch. And then I can change this to 1 inch. Come back here. Put in the text there. I'll put it up here. Again, as the scale goes up, the size of the text in the model space looks like it gets a lot smaller, although it doesn't print that way. And same thing, I would keep the multi-leaders as separate. I always put in the landing next to the text. Alright, so now if I go back to this roof 2, I see these two and I see this. But this is at 1 inch, not at 3/8, so obviously that's not right. But my point is that because they were created at different annotative scales, they're specific to that scale in that viewport. Now you can see them both at one time in model space if you want to. I find it a little bit confusing, but if you come down here and say show annotation objects, this is actually showing me both scales at one time. The larger text is actually the smaller scale. The smaller text is actually at the larger scale. This is for the 1 inch, that's for the 3/8. But once you get over here, up there, here, you don't see all of it together. Unless you've add multiple scales on here. If you've got that one turned on, you can see them both at the same time, and that gets to be problematic. So I'd always keep that one off. But if you want to see them both at the same time, you do that. Now the trick to the wall sections, or part of the process, is figuring out how much room you need to putting in those details. Because remember, anytime you put in a drawing, the title belongs underneath. So let me go back to the original wall section. So I've got 4 different viewports here, but for these over here, they're all lined up together. They're all between the details, and all these bubbles are referencing representing the details over here, and the benchmarks have to be put in at both scales. I tried early on to get them to work at, you know, to be able to put them in one and have them work for both. It really didn't work that way. The scales were too much different. So you had to put in the benchmarks both for the 3/8 and for the 1 inch. Questions? I'm sure there will be. Any questions right at the moment though? Okay, so it's not as bad as the elevations, but you do kind of have to build it step by step. And if you do the foundation and the framing first, it makes everything else kind of a little easier to deal with. So I'm going to stop that.